Hello, my name is Jacob Jones, and I will be demoing my final submission for the Socket project. And as you can see, I'm running on at least three distinct hosts, and I will be compiling the code before I run it on each machine. As you can see, there were no compiler errors. So before I begin, actually, okay, 117 Java, and I will begin the process or the programs. I actually think I have it somewhere in here. Is that it? Oh, it is. Nice. Okay, so now this is how my registration works. When the program starts, it will welcome the user, tell them the ports they're using, and then ask you to pick a handle. When you pick that handle, it registers that handle for you on the server. As you can see here, registration request for handle is successful. Now, if I try to, on a different user, register that same handle, it tells you the handle's already taken. And if I go up here and freeze it, you'll see handle A is already taken. Registration request from this place resulted in failure. So I need to pick a different handle. And as you see, it's successful. It goes through in the server. Now let me register everyone else. And again, just to show, like, if I choose A, it says no, that's no good. If I choose B, it says it's no good. If I choose C, it's no good. If I choose D, it's no good, because they've all been registered, and the server sees every single request and it displays a failure until I choose a handle that is approved. Okay. Now I will demonstrate my follow. So So let's say B wants to follow A. So once you type follow at A, it sends a request to the server gets it, and then it processes it. And you can see here follow request from B to follow A was a success, and the client is now aware that they are following A. If you try to follow someone that doesn't exist, the server returns a failure because G just doesn't exist, and the client is made aware. The same thing happens if you try to follow yourself. Like if B tries to follow itself, get a follow request from B, the follow B was a failure, and that's just because you can't really follow yourself. Now I will go ahead and set up the rest of my logical ring. Okay, that's the first logical ring. Now I will set up my second logical ring. Okay, A, B, and C are now following E, and B, C, and D are following A. Okay. Now, if actually, before I go on, I forgot to show this. If someone queries the handles, the server gets this is the follow requests that are coming through. You can see B to follow B was a failure, C follow A, D follow A, so on and so forth. When you query the request, it gets a query handles request, it displays the IP, and then it returns a list of all the handles. You can see that there's a list of handles, the IP address, and their ports. Okay. Now, since B, C, and D are following A, if A tweets something, hello from A, well, the client that tweeted is made aware that their tweet was sent around. The server received the tweet request. You can even see when the end tweet from A is received. And everyone who's following A gets the message. Okay. Now, since E never followed A, it never got the message. But since A, B, and C are following E, if E tweets hello from E, then, I have to go around and unfreeze the terminals. Tweet request from E is a success. Oh, oops, that's not it. Oh, B's wasn't frozen at least. So you can see on A, it received a tweet from E. B received a tweet from E. And there you go. C receives a tweet from E, and you can see the server processing it. Okay, dropping. Okay, so if B chooses to drop A, then B no longer follows A. The server gets a request, and it returns a confirmation that they're no longer following A. So now if A tweets hello again, B won't get it. Only C and E will, because they are, or sorry, C and D, excuse me. Only C and D will get it, because B is no longer following, and as you can see, trying to unfreeze the terminal doesn't. Oh, there's the tweet. It doesn't. You don't see it appear. But if B tries to drop someone, just like with following, tries to drop someone that doesn't exist, it gets made aware that trying to drop that person wasn't successful, and the server you can even see on the server side along with a reason. Okay. Now the only way query handles tweet and exit ever fail, like have a failure response, is if a tweet is propagating, because when a tweet is propagating, the tracker doesn't process other tweets. So that's really hard to time. So what I did was I made the server able to pretend a tweet is propagating. By typing tweeting, you will see it displays a message the server will pretend a tweet is propagating now. That's just more to let me know. But now any command that is sent to the server, it will be sent to it as if a tweet was being propagated around. So if A tries to tweet hi there, it says unable to process tweet, please try again. The server doesn't even acknowledge it. It just kind of sends back, it just kind of immediately sends back something saying, hey, I'm busy. And if B tries to query handles, the tracker is unable to process your request, please right now, please try again. The same goes for dropping. If someone wants to drop E, attempt to drop E was not successful, the server's not even going to look at it. And if someone tries to exit, it's unable to process your request at the moment, please try again. And this is the same for everyone, regardless of what command I do. The server's just not able to process it right now. And if I toggle it back off, it works just as good as new. I can query, I can tweet. Oh yeah, B dropped. Yeah, it all works. Okay, including the exit command. Now B is in a logical chain with A and C for following E. So like when a tweet comes from E, it goes from E to A, B, C, back to E, then back to the server. So if B decides to exit, it kind of has the same process as if someone drops someone else, or when B drops someone. So when B exits, now whenever E tweets, it has to update its logical ring. So tweet hello from E a second time. The server, you can see the server gets a tweet request. You see A gets it, C gets it, and E gets a confirmation the tweet was successfully sent, which means end tweet was sent to the server. And every other command can work just as good as new. The packet's not lost, and when you query handles B, because it's updated that B is gone. Okay. And if B comes back, decides to come back, you query handles again. Hey, there he is. Okay. So now, guess all that's left to show is exiting. So whenever the exit, the server. Oh, I forgot to unfreeze the server. Yeah, here you can see the registration request for B again. The registration request, and here's the query handles that I was showing. Now, B is left to request the exit tweeter. B is successfully left tweeter. The user account gets updated. A is requested exit tweeter. A is successfully left tweeter. User account gets updated. And when anyone exits, if this terminal will stop freezing, I don't know how to stop that. There, at least it did with E. You can see it says E was successfully left Twitter, and it displays user count 0. And all these people can come back and re-register whenever they want. And all the commands still work. And you can either control C to stop the server, or you can type exit and it will terminate the server. So yeah, that was my demonstration for my socket project, and hope you enjoyed it.